Okay, we're almost there. Number 18, the freight train. Okay, so I have a freight train that's 92 meters long, and it starts from rest with a constant acceleration, and a car just reaches the end of the train at that instant. The car is moving with a constant velocity. At 14 seconds, the car just reaches the front of the train. Ultimately, however, the train pulls ahead of the car, and again at 28 seconds, the car is at the rear of the train. Find the magnitude of the car's velocity and the train's acceleration. So I said, well, I'm going to begin problem 18 with the car at the end of the train. And I want to end the problem with the car back at the front of the train. So I really have two different time segments that I need to deal with. And let's see what we can do. So for the train, I'm going to call that distance x, and I'm going to say that it's going to be 1/2 at squared plus bit, but it starts from rest, so we can throw that out. And I know that x is going to be equal to 1/2 a, t is 14 seconds. So when I did that, I got that first distance for the train to be 98 times whatever the acceleration was. Okay? And then I said that Vf is equal to Vi plus At. That's 0 because it started from rest. So for the train, Vf is simply A times 14 seconds. So it's a 14A. Okay? Now, for the car, it travels 92 meters more than the train because the train is 92 meters long, so it's got to get to the front of the train, but while that's going on, the train is still traveling. So it's going to wind up that the distance for the car is going to be x plus 92 meters, because it has to make up the length of the train and then whatever distance the train went. Okay? And the car catches up with the train eventually, so the final speed of the car is going to equal the final speed of the train. And I know that the final speed of the train is already 14A. Okay? So what I said was that distance is equal to speed times time. So distance is x plus 92. And I'm not going to worry about the meters. The speed is going to be 14A. And it's going to last for 14 seconds. So x plus 92 is equal to 196A. So I said then x for the car was equal to 196A minus 92. Or x, I'm sorry, is defined as the distance for the train, so that's what the train has done. Okay. So I know that if x is 98A up here, then 98A is equal to 196A minus 92. So when I bring this over to here, I have a negative 96A is equal to a negative 92. So A is going to be 92 over 96, or I got 0.939 meters per second squared. So there's the acceleration of the train. And now I need to go back up here and find the final speed of the car. Well, the final speed of the car is 14A. 14 times 0.939 meters per second squared, and this is actually 14 seconds. So the final speed of the car is 13 meters per second. Alright, that was number 18. Let's go on to 19. We're getting there. So 19 is the Tiger receiver. And again, if I had typed this up, I would have made it a Cougar receiver. So let's take a look. So a Cougar receiver at the line of scrimmage accelerates from rest, so VI is 0. Along a straight line for 3 seconds, so the first time is 3.00 seconds. Then within a negligible amount of time, he changes his acceleration, so I'm going to call that A2 is 1.10 meters per second squared. And he continues this acceleration, so he maintains that for 2 seconds. And at the end of that, he has a final speed of 6.40. And they want to know what was the acceleration here. Okay. So I said, well, VF equals VI plus AT to begin with. So I know this is 0, so VF at the end of the first period is A1 times 3 seconds. Well, that final speed at the end of the first period becomes his initial speed for the second period. So if I go back to VF equals VI plus AT, and I'm now in the second time frame that they're looking at for 2 seconds, then I can say, oops, sorry, that's not the number I wanted. Alright, so I can say 6.40 meters per second is equal to VI, which was 3.00 seconds, times A1, plus acceleration 2 times 2. Acceleration 2 is 1.10 meters per second squared. Time 2 lasts for 2 seconds. So that's 2.20, which I bring over and subtract from 6.40. So now I have 4.20 meters per second is equal to 3.00 seconds times A1. And when I solved for A1, I think I got 1.4 meters per second squared was my acceleration during the first time period. Okay? Alright, and then I think we have number 20 to deal with. Okay. So let's look at number 20. So number 20 says, a go-kart moves according to the velocity time graph shown in the right. Make a position time graph and make an acceleration time graph. So my position time graph, distance versus time. So it accelerates from 0 to 20. So I'm going to need a bit of a curve to show it accelerating. Then it maintains a constant velocity. So its speed increases at a pretty constant rate. And then it accelerates again. So there's my distance versus time. It's not very pretty, but you get the idea. Acceleration versus time. So take the slope of the line on the velocity versus time. You have a positive slope. And then you have no slope at all because it's moving at a constant speed. So that's A, that's B. And then C, it has another positive acceleration. Now that positive acceleration is even steeper than the first one. So it needs to be a little bit higher. And this one over here was section A, B, and C. Okay? So I'm going to stop this one and then we'll do the multiple choice and I'm going to go to bed.